In this video, I am going to talk about p orbitals, and it will also be a summary of s orbitals. For purposes of this discussion, I have moved the helium element to the second column of the periodic table of elements. P orbitals are dumbbell-shaped, so the 2p through the 7p orbitals are those orbitals that are part of the electron configuration for elements in columns 13 through 18 and rows 2 through 7 of the periodic table of elements. I have boxed the elements of the p block in green. So in this video, I am going to show you how to write the electron configuration for nitrogen, neon, silicon, and chlorine. So let's start off with nitrogen. So nitrogen, now like we've been doing before, we're going to read the periodic table from left to right. So here we go. Here's the 1s2. How did we get that? The 1 and the s2. Now remember, we're doing building blocks. We're just adding more and more configurations to this till we get to nitrogen. Now let me just erase this part so we don't get confused here. Now let's go to the second period. So here we go. Here's the 2s2. How did we get that? Here's a 2. Here's the s2. All right. Now moving right along here. Let's erase this so we don't get confused. Now we're going to hit nitrogen in the p block. But how do you read the p block? Here you have p to the 1, p to the 2, p to the 3, p to the 4, p to the 5, and p to the 6. That's how it's read. Now, moving right along here. So, nitrogen, we're going to hit it right here. Boom. So it's in the second period, it's in the p block, and it's in the third column of the p block. So it's 2p3. Now, how do you know you have the right number of electrons? Well, you add the superscripts, which is 2 plus 2 is 4, plus 3 is 7. And that's equal to the number of protons in a neutral atom of nitrogen, which is 7. So moving right along here. This is getting really exciting. I really love electron configurations. Once you get the hang of it, you'll really love doing these. So moving right along here, we're going to go on to neon. Now neon, once again, this is all we've been doing, reading the periodic table from left to right. So here we go, 1s2. How did we get that? Here's the 1, here's the s2. Now the next one is, let's erase this so we don't get confused here. The next one is right here, boom, hit it. Here's the period it's in, 2, and then s2. We just got to do these building blocks. It's all building blocks. Now let's erase this so we don't get confused. Now we're going to hit neon in the p block. There it is, boom, neon. So it's in the second period, it's in the p block, and it's in the sixth column of the p block. So it's 2p6. Now, how do you know you have the right number of electrons? You add the superscript, so that's 2 plus 2 is 4, plus 6 is 10, which is equal to the number of protons in a neutral atom of neon of 10. Okay, so moving right along here. Like I said, I love doing these, and you're going to become an expert pretty soon just doing these. So moving right along, let's move on to silicon. So silicon, reading the periodic table from left to right, and we're going through the rows as usual. Here's the 1s2. How did we get that? Here's the 1. Here's the s2. Now, moving over to the second period. Here's the 2. Here's the s2. It's like you're adding configurations. That's all you're doing on these, and it's so much fun to do. Now, silicon is not until you get to atomic number 14. So you're going to complete this whole p block. So boom, hit it all right here. So here's a 2, here's a p block. It's the 6th column of the p block. So 2p6. Now that being said, let's go on. Here we're going to hit this one. So it's 3, s2. And now you're going to hit the p block where silicon is. Boom. Here it is. There's silicon. So that's the 3rd period, p block, and it's in the 2nd column of the p block. So that's 3p2. Now, do you have the right number of electrons? Well, you add the superscripts. That's 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 2 is 14, which is equal to the number of protons, which is 14 in a neutral atom of silicon. So that being said, moving right along here, we're going to move on to the last element, which is chlorine. And chlorine, as you can see, all these are getting longer as you go through the periods. So chlorine, once again, reading the periodic table from left to right, that's all we've been doing in all these. So you go 1s2, how did you get that? Here's the 1, here's the s2. Moving right along here. So the next one is going to be your 2s2. Here's a 2, here's the s2. Now, moving right along. You're going to complete this whole p block because chlorine is not until you get to atomic number 17. So you're going to complete this p block, which is 2p, and it's in the 6th column of the p block. So that's 2p6. Now moving right along here, let's go to the 3s2. Here's the 3, here's the s2. Now we're going to hit chlorine. We're going to hit it here in the p block. Boom, there it is. So it's in the 3rd period, p block, and it's in the 5th column of the p block. So it's 3p5. So how do you know you have the right number of electrons? You add the superscripts. Once again, here we go. We add the 2 plus the 2 is a 4, plus the 6 is a 10, plus the 2 is 12, plus the 5 is 17. So that's 17 electrons, which is equal to the number of protons in chlorine, which is 17. And remember, they're all neutral atoms of the element that we're dealing with here. So that being said, one more thing I want to talk about in this video is energy levels. If you remember in a prior video, I talked about energy levels. And why am I going to talk about this? I'll tell you right now. So the formula for energy levels was 2n squared. And there are 3 elements here, neon, silicon, and chlorine, all share the same configuration of 2s2, 2p6 for the 2nd energy level. And what I'm trying to get at here is that we're dealing with the 2nd energy level right now that I'm trying to share the similarities in. So in this case, the n is going to be 2. So if you take the 2, substitute the n with the 2nd energy level of 2, and then squared. So it's 2 times 2 squared is equal to 2 times 4. Let me write that again. My 4 went a little bit sloppy there. So you can write your 2 times 4 is equal to 8. Now what I'm trying to get at here, I'm going to erase this right now because I want to show you something. So let's write that similar electron configuration that neon, silicon, and chlorine have. I'm going to write it right here. It's 2s2, 2p6. And if you add the superscripts, which is 2 plus 6 is equal to 8, that's the maximum number of electrons you can have in the second energy level. And as you can see from the energy level formula, we came up with the 8, which is, once again, the maximum number of electrons you can have in the second energy level.